Hello, we are Group 36 and this is our video presentation on IoT product families for smart home applications. With the advent of Internet of Things, it has become possible to create smart home systems that help residents with several functionalities that would otherwise require human effort and time. The smart home market has hundreds of product lines from several companies. Each product line is made with different technologies in hardware and software. For a normal person who is just beginning out, all of this could be overwhelming. They would also certainly want to know what's going in their homes and what's going out of the homes. We hereby present two IoT product lines that we found interesting from the point of view of a newly starting user. There are big players in the market like Philips, Google, Amazon that are targeting the higher end of the market with slightly expensive products. But for someone who is just venturing out, they are more likely to choose cheaper products that are available. One of the companies that offers such devices is Tuya. Tuya calls itself a global IoT development platform, an umbrella organization that provides all the required resources for the development and deployment of a product. As a smart home enthusiast myself, I was looking into the local market scene for interesting products. I bought a bulb from Gridwatt, and after some tinkering and playing around, I found that the bulb is actually a rebranded product from Tuya. A quick search on Google later revealed that most of the market's products are just rebranded products from Tuya. All these companies might have different products with different brands, but they still have the underlying technology same, which is from Tuya. Tuya offers various platforms to develop solutions, products, applications for the mobile and cloud, and even perform data analytics. They have various product solutions for various business sectors. Some of the product solutions are mentioned here. Later, the relevant assortment of the products for smart home are categorized on their website as shown in this figure. One product from each category is taken into consideration for the use case, which comes later in the presentation. This picture from Tuya's website gives a model for a smart condominium with few devices as an example. This is going to be used as the use case in this presentation. Coming to the functionalities and the physical components, the control hub is the pseudo-brains of the whole system. It aggregates all the sensor data and sends it to the cloud for processing. It also has some local application logic so that it can still control devices locally. Then there are actuators like the 3-gang switch, smart bulb, desk, curtain controllers. And there are sensors like the security camera and the water detector. Then there are devices like the door lock, water heater, smart wardrobe, and robot vacuum, which have both actuators, sensors, and those can also be classified as embedded devices. This is the use case that we are going to look into. The door lock and the security camera work together to find the presence of the people in the house, and this helps to switch on or off several devices. And also, in addition to this, the robot vacuum can be instructed to try and do most of the cleaning when no one is at home. This is a part of video that is available on Tuya's website. This shows the earlier mentioned use case. An abstract physical view of the system is shown where the devices are either connected to the network or to the hub, which acts as a gateway. But all the data is sent to the hub, which transfers it to the cloud where most of the processing is done. This brings us to the deployment view of the use case. The bulbs and the curtains are connected to the controller via the Zigbee. The rest of the devices are connected over Wi-Fi. The control hub sends the data through the internet to the cloud. The red arrows indicate the flow of data and the blue arrows indicate the flow of control. Coming to the sequence diagram that shows the normal use, from the video footage from the security camera and the information about the log state, an application that's running on the cloud estimates whether there is someone at the home or not. This information is sent to the control hub, which uses this to control the devices according to the predefined user specifications. Adding a new device to the system, to the Tuya ecosystem takes some effort, as there are several devices with different technologies in them. The process is always not the same, but it's more or less similar. An example of a device which uses Wi-Fi as the connectivity protocol is shown. The Wi-Fi access point name and password are shared to the new device from a user device, and then the new device attempts a connection, and once this connection succeeds, uh, this sends the pairing data to the user device. The user device then uses this data to gain authentication from the Tuya cloud. And once this is done, the confirmation is sent to both the device and the user. The user then updates the device data, the control hub, uh, after which it can start controlling the new device directly instead of the user sending the control commands to the new device. The fault analysis: if the internet connection is lost, it looks like most of the processing in the Tuya ecosystem is done on the cloud, leaving very simple logic running on the things when there is no hub. But in case if there is a hub, the system still works on the local network, although with a limited functionality. When a device stops working, depending on the device, the consequence can either be negligible or dangerous. A faulty bulb is acceptable, but not a faulty door lock. The hub usually checks for the device and keeps track of their digital health. If it is the hub that fails, there is still a way for the cloud to take over the control, emulating most of the software functions of the hub, as long as the things are reachable, uh, at least over an IP network. But this is still a beta feature in Tuya, and they are going to release this soon. If there is a conflicting commands from the user, the products are found to follow the most recent commands, even if it's conflicting. Concerns about privacy. From the earlier mentions, Tuya is slowly infiltrating into each and every store. Uh, so Tuya is mostly a Chinese company, though. So what about privacy, you may ask? Before you use a Tuya product, you will see a privacy policy which does not give much information except for the statement saying we will not abuse your data. However, it is made known that your data is sent to China, of course. But as we think about it, do we also transfer a lot of data to the United States? I mean, like to the tech giants like Google, Microsoft, Facebook, and we don't even think about that. So Tuya is not some obscure Chinese company, but it's a major global player. Uh, till date, there is no known case of data abuse by Tuya. So finally, it's all up to the user whether they want to buy a product or not. Now, the life cycles for the device and the application, along with their concerned stakeholders, is as follows. The stakeholders are given in the blue. Basically, mostly here in these stages, like the installation, the operation, and the decommissioning, the user is the main stakeholder because as these are not industrial products, these are just commercial consumer products. So user has to take care of such stuff. But then the construction, production, and the updation is mostly taken care of the developers, testers, and the administrators at Tuya. Coming to the application, as mentioned earlier, the most of the applications are deployed on cloud. So again, here there is less intervention of the user except for the maybe reconfiguration of the application based on their needs. The rest is mostly maintained by the developers, testers, and the administrators.
Hi, I'm Juan, and I'm gonna talk about Home Assistant. So what is Home Assistant? Home Assistant is a bunch of software that you can download from the internet. It is free and open source. Thanks to it being free and open source, it has a focus on privacy and local control, so you are sure of what is running on your system. To interact with it, you can go through the web via mobile apps or via voice commands. Home Assistant is just a bunch of software and they don't manufacture any kind of products. So if you compare it to, for example, an Amazon Echo, the user will expect a lot more setup in his part compared to it. We're gonna do an example. So the user wants to do the following 3 points. He wants to monitor the power consumption during the day. He also wants to turn on the power appliances when the electricity cost is low, for example, at night. And he also wants to receive a notification when the power appliance finishes. In order to do so, we will have the following elements. We will have some sensors. This would be a power meter connected to the internet in order to know the electricity cost. And we will also have some power meters connected to the power appliances. So that way we can detect when the power appliance finishes. We also need some actuators, like a switch that turns on the power appliance. And we also need the networking. So we would have a normal router that probably everybody has at home already. And we also have a storage. The data that will be flowing in the network isn't really big, so the data can be stored probably in the SD card of a Raspberry Pi. That will be the controller also. And the user can interact with his phone, tablet, desktop, laptop, or any kind of device with the Raspberry Pi. And he can configure it and check the statistics. Here's the deployment view of what we have just described. We have on the bottom we have the power meters and the power appliance with the actuator, and all of the data from the sensors is flowing to the Raspberry Pi, and the Raspberry Pi decides when to turn on or off the power appliance. All of that data is flowing through the Wi-Fi. And more infrequently, the user can, for example, with his phone, interact with the Raspberry Pi and configure and change and take a look at the data and change the threshold values or whatever he wants to do. Here is the sequence diagram of the system. The power meters are frequently sending data to the Home Assistant server, and the server processes the data and decides when or if it should power on the power appliance. If we want to add a new device, first of all, the user, for example, through his phone, has to configure it on the server, the Raspberry Pi. Later, he will configure the new device and for it to be able to connect to the Wi-Fi. Once the device is connected to the Wi-Fi, it is connected also to the Home Assistant server, and everything should work. For a fault analysis, in case of an internet connection lost, we don't think that would be a problem because with Home Assistant everything is running offline, so there's no need to talk with any cloud in order for the processing to be done. Obviously, if there is a failure on the local network, the devices won't be able to talk to each other and the system will break. In case of a device breaking, for example, if it's a sensor on an actuator, it could probably be detected by the device not responding to the command, or by an abnormal measurement like a negative power draw or something like that. The user is responsible to replace and fix the part. If the Raspberry Pi fails, is the heart of the system, the microcontroller, and obviously the system will break. And in case that there are conflicting commands sent, the user should be able to override any kind of behavior, so the user has the last word in what should be done in the system. In terms of privacy, this is the strong part of the system. As it is open source and everything is running locally, there should be no concerns about privacy. The life cycle of the application is the following. The reconstruction of the software is all made by the developers. Those are the stakeholders. The deployment has to be done by the user. We have already seen he is responsible of doing all this process. The execution should be automated, and the development team is there responsible for that. Determination has to be done by the user because he has full control over the system at all times, and the user is also responsible for reconfiguring the system. Now we're moving on to the interaction between two distinct product families. So the use case is the following. The user wants to automate the lighting in his room. In order to do so, he will use a light sensor, smart bulbs, and curtains. If there's enough sunlight, the curtains will open and the light bulbs will turn off. If there's not enough sunlight, the curtains will stay open. That way, the user has light at all times, and he isn't spending too much money in electricity. So in order to do so, we will need the following components. Smart bulb will be the actuator. We also have another actuator, the curtains. We'll have the Home Assistant server, a Raspberry Pi, similar to the previous example. And the light will have several light sensors in order to make a precise measurement of the light level. Here's the deployment view of the model. It's similar to the previous example. We have a bunch of sensors, and all of that data is sent to the Raspberry Pi, and the Raspberry Pi decides if it should actuate and in what should it actuate. And all of this data is going through the Wi-Fi. And the user, once again, through his devices, can change the configuration and take a look at the data.
Coming to the normal use of the system, the raw sensor data is sent from all the light sensor nodes to the Tuya cloud server, which aggregates the sensor value and sends a single value like luminance index to the Home Assistant. Here, the application logic runs and it determines various actions that need to be performed based on the luminance index value it received. It performs values like switching on or off a bulb, or maybe changing its brightness, or opening or closing the curtains. Adding a new device to this network is a bit complicated. First, the user has to add the device to his Tuya Smart account, which is basically getting access to control the device over the Tuya cloud network, and then also linking it to a Tuya IoT platform and receiving an authentication key, and then finally sharing this authentication key along with the access ID of the new device with the Home Assistant server so that it can request access with this data, which is accepted by the Tuya cloud server. After everything is done, the Home Assistant server can control this device via the cloud, via the internet. The fault analysis, if all the Tuya devices need internet connection to work with Home Assistant server. But there are also some third-party plugins that can change this. These are out of scope for someone who is just beginning. And there are even more advanced methods like flashing custom firmware onto the devices. If the light sensors stop working, if only one light sensor stops working, then the system still works, maybe with less precision, but it still does. But if a bulb or the curtains do not work, then the system will not work as intended to be. And if the Raspberry Pi, which is running the Home Assistant server, breaks, then the entire system is made useless. In case of a conflicting command from the user always gets the priority than some other sensors, maybe. Finally, the life cycles of these combined system is almost similar to the previous ones with little changes. Uh, Here, the teams working on Home Assistant and Tuya take care of the application development and testing. The deployment is mostly done by the user. Uh, this also has different steps, like we have mentioned, how to add a new device to the system. This differs from both Home Assistant and Tuya. and the execution is almost automated because there are pre-configured. And the termination, again, it is dependent either on the user or if the devices or services fail beyond a point of return. And the reconfiguration can be up to the user because as the Home Assistant is open source, the user can always access the source code and reconstruct the entire system and reconfigure it up to his requirements.